Okay, we're about to do problem 15, calculating the width of a river given point A, point B and a tree on the opposite bank. You're told that the distance between A and B is 50 metres, the angle at A is 56 degrees, the angle at B is 40 degrees. You need to calculate the distance across the river. Okay, to do this problem, remember we're doing trigonometry of right-angled triangles, and A, the triangle made by the point A, the tree and B is not a right-angled triangle. So our first step is to drop a perpendicular from the tree across the river and divide our triangle, non-right-angled triangle, into two right-angled triangles. The distance between A and B is 50 metres. So the distance in the left-hand right-angled triangle across from A to perpendicular to a point perpendicular to the tree is 50 minus x metres. The distance from that point to B is x metres. Okay, so we now have our two right-angled triangles. But we're also going to use skills we developed leading up to the last test. If you remember back from the last exam when we transposed, we're going to have to use transposition in this problem. Okay, so remember back to this type of problem when we have AX plus CD equals BX plus EF. Our first step to make X the subject was to get all the terms in X on one side of the equation. In this case, I've chosen to make it the left-hand side of the equation. So I'm going to move BX from the right-hand side and move it to the left-hand side of the equation. I'm also at the same time going to remove CD from the left-hand side and move it over to the right-hand side by subtracting it from both sides. So I then end up with, on the left-hand side, AX minus BX equals EF minus CD. Noting that we have all the terms in X on the left-hand side and all the terms without an X on the right-hand side. To make X the subject, we need to firstly factor out X from the left-hand side. So we end up with X outside of A minus B equals EF minus CD. By dividing both sides by A minus B, we isolate X and make X the subject. So we end up with X equals EF minus CD over A minus B. Okay. Now we want to calculate the width of the river. So we're going to let the width of the river equal W. Now we're going to use simultaneous equations, developing two equations using tan of theta. Remembering tan of theta equals opposite over adjacent. So that's how we create our two equations. So the tan of 56 degrees equals the opposite, which is the width of the river, over 50 minus x. The second equation is tan of 40 degrees equals W over x. We now, on the left-hand equation, multiply both sides by 50 minus x, and on the right-hand equation we multiply both sides by x to remove the denominators. Then, if you notice, both equations are equal to W. So using substitution, we get 50 minus x, in brackets, times tan of 56 degrees equals x tan 40 degrees. Expanding and removing the brackets, we end up with 50 tan 56 degrees minus x tan 56 degrees equals x tan 40 degrees. Now, using the technique we discussed previously, we need to get all the x's on one side of the equation to solve for x. We add x tan 56 degrees to both sides, so we end up with 50 tan 56 degrees equals x tan 56 degrees plus x tan 40 degrees. Factoring out the x, we end up with 50 tan 56 degrees equals x outside of tan of 56 degrees plus tan of 40 degrees. Dividing both sides by tan of 56 degrees plus tan of 40 degrees, we end up solving x. X is equal to 50 tan 56 degrees over tan of 56 degrees plus tan of 40 degrees. Even though we've found x, we haven't finished our problem. The problem says calculate the width of the river. So then we have to substitute x back into one of our original equations. Okay, so I've chosen equation x tan 40 degrees equals the width of the river. So substituting in, we end up with the width of the river is equal to x, which is 50 tan 56 degrees over tan of 56 degrees plus tan of 40 degrees times tan of 40 degrees. Putting that into our calculator, we should find that the width of the river is 26.79 meters.